Right, let's get started. Okay, so everybody got their project one grades back, and we had some consistent difficulty with getting the EMR step to start. So what we're going to do today is we're going to address because on the next project, EMR step will also be a requirement. So many things through EMR, so we have to get that process down. Are there any general questions on the grading criteria? Okay. So what we're going to do right now is it's going to require significant participation from all of you because it seems that a lot of you had the same problems, but there was also a pretty big diversity in the kinds of problems that we saw. So we're going to go through the most common errors that we faced with trying to submit an EMR step and run the code asynchronously. Sound good? Yeah.
So is any of the process of the like getting the EMR step or going to the online exam just to
I haven't written the exam. That's a good question, but I haven't written the exam. So after I write the exam, we will have an exam review session at some point. The more I think about it, the more I keep pushing the exam out because I also want to introduce project two before we start the exam. So you guys will just have more time to work on it. So that would be good. Project two is mostly going to focus on managing infrastructure and smoothing everything out because as far as the Spark code is concerned, you all are good there. Like I'm pretty satisfied with what I saw as far as Spark goes. So I don't feel like we need to really cover it in further detail unless there are specific questions that you all have on extra depth we could go into in certain places. But in general, I'm really happy with everyone's code. Questions about that? Okay. So the output from this class is together, we're going to create like a new markdown file or something, and we're going to put it on GitHub, and that's going to list out common errors we see and the solutions to those errors. So that if you try and create the EMR step again in this project, in project two, and you see the error again, you'll know what to do. Because a lot of the time when you have an error in Spark, the message you get is not indicative of how to solve the problem. And I think you all have noticed that. It's really annoying. A lot of figuring out how it works is just trial and error. And I wish it was better than that, but it's not. Especially since Spark itself is not what I would call a fully functional piece of software. There are issues like it'll tell me I'm running out of memory when I have 600 gigabytes of memory and I'm using 3 megabytes of data because this is a test data set. I'm like, no, you're not out of memory. What's the actual problem? It's like we'll have a significant discrepancy between the amount of data I'm using, which is very small, the amount of memory I actually have, which is very large. It's telling me it's anyway, which is clearly not possible. It can't be running out of memory. So an example of this happening is a few months ago, I was working with another engineer trying to put something from Spark into our pipeline, and he was working with a smaller data set, and he got an out of memory error. I'm like, no, that's some BS. We're not out of memory. And then we figured out that if you have a specific combination of things that you do in Spark, it will actually say it's out of memory regardless of how much data you use and how much memory you actually have. What we discovered is if we have a UDF in Python and we and we are writing to Parquet like in the same stage, then we'll say it's out of memory for whatever reason. So our solution was cache it first, eagerly compute it, then write it to Parquet. Spark makes me so mad sometimes. In our company stand-ups, I will constantly complain about how terrible Spark is, and this is the reason. This is also the reason why I'm the one who primarily works on our identity pipeline at Count because no one else wants to do it. This is why. Okay, so let's create a little run book so we can go through some common errors and we'll figure out how to fix them. And I'll also explain, why that problem is that problem. All right. So who has an error they got that they want to talk about? Yeah. Import pandas. Okay. EMR does not come with pandas on its distribution by default. So if you want to install pandas on EMR, you will have to use a bootstrap script. A bootstrap script is something that you can apply to every node in the cluster before all the steps start up and before it's ready to accept connections for Spark and everything. So you can do it that way. However, the code we're writing doesn't actually need pandas. So why are you having this pandas error? The problem is when you're using Spark Connect, using the PySpark API, PySpark will use pandas to communicate with Spark. So if you use Spark Connect, it will automatically try and use pandas. But if you don't use Spark Connect and you take this line out, which is what you're supposed, what did I just do? Which is what you're supposed to do on the EMR step, it will not use pandas because it's not using Spark Connect. So this is why when Dylan asked the question, why am I getting this import pandas error? When I'm submitting a step to EMR, I'm not importing pandas. I don't have anything to do with pandas. What's happening? This is why. And this is not indicative of what's going wrong. It's kind of disconnected because you would think that if any part of PySpark required pandas, AWS would include it in its distribution, but no. This is the kind of thing. Yeah.
Okay. Is Spark? Okay, so I think what I don't understand is this line, is this remote line? Is this only for? So this is obviously not if you want to run scripts. This is only for a notebook.
It's not strictly speaking only for a notebook. It's for a remote connection to Spark. So if this code is not running on the master node, you need this remote tag.
So even if I were to have kept my Python script on my machine and hadn't SCP'd it to, did I SCP it to the node? No, I SCP'd it to S3.
Yeah. So no, because what submitting an EMR step does is like when you start up, where did it go? Where's the start EMR dot? There it is. Okay. So when you go through start EMR, you will give it an S3 location for really the entry point file and the rest of the code in the zip file. What the EMR master node does is this tells the EMR master node, pull your code down from S3 and then run it locally. That's what the master node does when you give it these URLs or URIs. So that's what it's for. So even though your code is stored in S3, before it starts executing, it's downloaded so that within the master node, it can execute locally. That's what it's for. When you're running code in a notebook, the code in your notebook is executing on your machine. This code, right here, this code right here is executing on my machine. And so this is why we need the remote tag. And like we covered last time, in order for Spark Connect to be available, we need to SSH into the master node and create the port forwarding so that Spark Connect on port 15002 is accessible to us from localhost. Does all of that make sense? Because there's a lot of parts that need to be connected in order for this to work.
So when we are using it and running it in notebook, do we have to will this not work if we don't have pandas installed?
Probably, because Spark Connect needs pandas.
Have it imported?
Yes, it'll probably internally import it, like in the library. The crazy thing about Python is that you can put import statements like anywhere. There are no guard. You can put an import statement in a function. Python doesn't care. You want me to show you? Like, this is stupid. This is so dumb. All right. So, all right. Import JSON. And then you can do object equals JSON dot load s, which is just JSON deserialized. And we have an object. Nope. That's not what we're supposed to do. We have an object and it has one attribute foo, and that has a value of 5, and it has another attribute bar, which has a value of false. Just the boolean. Is that no? We need the brace. Oh, yep, that's right. Thank you. Okay. Stupid. I wonder if actually the import was global. I'm gonna check if the import was global. Let's try it again. There we go. So the import is local to that function. So it didn't, so even though we imported it locally in the function and it wasn't imported globally. Because we know that if we move this import into the global scope and we do it outside of a function, it'll be available everywhere. But yeah, this is stupid. But I've actually taken advantage of this. Like I've actually had to use this before. I've had to import inside a function before instead of importing it in a global scope. You want to know why? It's really dumb. So, has anybody heard of protocol buffers? Protobuf? So, protobuf is like a lightweight agnostic serialization format. And you can declare like these generic struct-ish types in protobuf, and then you can compile the protobuf file to a bunch of other languages. And so that allows us to basically write one version of an interface and then have like implementations of that interface in a bunch of different languages without us having to rewrite it all the time. So it's really nice. Here's the crazy thing though. So when you're using Spark and when you execute a UDF in Spark, it actually takes all of the code for the UDF and all of its dependencies, serializes the code, moves it over to the core nodes so it can actually be executed. Does anyone, like, people understand that process? Because so like when you execute code in Spark, this is an interactive process, right? Spark on the core nodes doesn't have access to your machine, right? The communication happens over a network. And so when you declare a UDF like foo, the core nodes that are actually executing the code, they don't know that foo exists. They don't have the code. So you have to actually send the code over for it to be executed. So the code itself has to be serialized and then deserialized. And Python is also crazy in the sense that if you have Python code as a string, you can literally take a string and execute it as if it was Python code. I think that's called eval. Like the amount of hacky BS you can do with Python is completely, it's unhinged. All right. I think it's called eval. Watch this. Stupid. Like, watch this. I spelled printing wrong, but you get the idea. I've used this before too. Huh? I've used eval before. So, okay. You want to know what I used eval before? It was so dumb. All right. So, okay, maybe it wasn't that stupid, but I think it's stupid. So we were doing this research with generative AI. We were trying to figure out, this is when people thought generative AI would be like useful. So so we were doing this research with generative AI, and we wanted to find out if it was good for anything. So what I did was I set up a series of experiments where we wanted to figure out, like, instead of writing, SQL or some other query language in order to access a database, what if we could write just questions in English, and then an LLM would understand what the database was like, and then translate that English question into, something like a SQL query and other code to aggregate the results and then give us the answer to the question we asked. Like, that's not a complicated idea, but we wanted to see if it could happen. All right. So this was like a year ago. We were using Google's generative AI, Gemini, and other part of Google's AI stack like Bison. I don't know if you've heard of it. So Google Cloud Platform has this AI stack called the Vertex AI, and that enables you to make calls out to an LLM with prompts just from Python. And what we did was we sent it a prompt, and we sent it like a prompt template. And we were like, okay, we're describing the database, and the hypothetical database we described was just a like a normal Dynamo table. You remember Dynamo from the lecture we had, where the partition key was somebody's last name, somebody's family name. The sort key was their first name, and the only other attribute in there was age. So we had partition key is last name, sort key is first name, and the only other thing we had is age. So we described that in copious detail in English to this LLM. And then we asked it, okay, using the description of this database, I want you to generate some Python code that will answer this question. What is the average age of everybody named Smith? Now, what the code you would actually write is you query the Dynamo partition per for Smith, grab every member of that partition and take all the ages and average them up and then return it. And that's sort of what the LLM did, but it couldn't even do that properly. Like I would ask it to find the average age of a person named Smith, and it wouldn't do that correctly. So I gave it an example, an exact code example of how I would write the code to find the average age of a person named Smith. And then I said, find the average age of everybody named Martin. Like, I only changed the last name and it still didn't get it right. but I used eval to run the code that the LLM returned because it was just a string in the response. Hate the fact that this exists, but you can do so much hacky stuff with eval. It's evil. Like the fact that this exists is so stupid. I'm pretty sure I can even call foo from here. It's so dumb.
Okay, so why did you have to import something within?
Oh, geez. Okay. So, all right. So I was explaining why you have to serialize code for Spark because the core nodes don't actually know that the code exists because you're writing it interactively. So the code isn't actually on the core nodes when you write it. So after you write the code, you need to serialize the code and then send the code over to the core nodes so that it can be executed. The thing is that when you use a library in the code that you're sending over, it also has to send over the library and all the contents of the library, right? The problem is Protobuf, whose entire job is to serialize and deserialize things, the library is not serializable. You can't serialize the library. You can't serialize a library that's supposed to be used for serializing. So what I had to do was, instead of importing the library in the global scope and then sending the code over, because the code was using the library that was already imported, instead I imported the library within the function. And then if you do that, then Spark doesn't feel the need to send over the library because it's supposed to have access to it in the environment that's actually executing the code. This is the kind of stupidity you have to deal with where Spark is concerned. It's so dumb.
So how's it deciding what it's serializing it's sending over?
So I don't know the details of that. It probably does like some kind of closure. Like it'll scan your code and look for elements from the global scope that you're referencing. So, let's say we, imported JSON globally in the global scope like this. And we're referencing JSON, right, in here. So it'll look for anything that you reference, and then it'll bundle that into the thing that you send over.
Okay, okay, but I think this is actually something I regularly struggle with. Like understanding where these things are running. Like the idea that Pandas needs to be installed in order for me to connect something remote and but I don't understand where Pandas needs to be installed because I don't understand exactly where my code is running.
So Pandas needs to be installed on your machine because this code is running on your machine, right? You're creating the Spark session on your machine. The Spark session lives on your machine. And so Spark Connect is using Pandas for its communication stack between your machine, which is the client, and the Spark Connect server running on the master node. So it's using Pandas to facilitate that communication, which is why it needs Pandas. But if you don't use the remote option, you don't use Spark Connect, it doesn't need to use Pandas because the communication protocol is different because we're not using Spark Connect. So this is why even if you're not importing Pandas in your code, you're going to find, oh, we can't find Pandas over here. That's how you would fix it. And because when you're running code as an EMR step, you shouldn't be using Spark Connect anyway, because Spark Connect is for, remote communication. So does everybody get that? Yeah. Okay.
Still, I'm getting 1.5 on this.
That after running for 5 minutes, so there must be some other piece of code that is referencing Spark Connect. Do you have the save method defined? Did you copy my code like from the repo? Do you do like what was it? PySpark.sql.connect.dataframe.dataframe.save equals save. Is that line in your code? Yeah. So you're referencing, if you reference the module Spark Connect, it'll import Spark Connect, and then it'll import all the dependencies of Spark Connect, which includes Pandas. So you have to remove that line too. Yeah. See what kind of crap we have to deal with? I'm sure you're not. I'm sure at least 6 other people in this room have seen that error. Yeah.
Do have a band-aid.
Yeah.
If
No, share your Band-Aid fix.
you can do an extra EMR step in your start EMR script that just runs pip install pandas
Yes.
stuff.
Yes.
We got it.
That's the equivalent of a bootstrap script.
Yeah,
Like that's the same thing. So
except one last thing up.
no, it said you have to start another step. So there are a few ways to fix this, right? Create a bootstrap script. Script to install pandas. Or I'll clean this up before we upload it. Or remove any references to Spark Connect in your code. So that includes, right, the dot remote calls. That also includes PySpark.sql.connect.dataframe.save equals save. Is that what this looks like? Does it look like something else? I always forget. Hey, there we go. Okay, I got it right.
So hopefully default this.
Like, how are you supposed to know this? You pull your hair out for 3 years. The hard way. No, it's really dumb. I mean, you can get some clues though based on like what line the error occurs in, right? So I'm willing to bet like the second PANDAS error that you got happened at the line where you tried to add the extension method save, right? I bet it happened at this line because Spark will import things lazily, or Python will import things lazily, and it'll run the import code lazily. So I'm willing to bet that it happened right there instead of earlier. Did it happen there? No?
Oh.
Okay. So if you have the dot remote, it'll happen when you're building the session. If you don't have the dot remote and you have this statement to include the save extension method, then it'll probably happen there. So if it has an import pandas statement at the top, then it's not going to work because EMR doesn't have pandas installed by default.
It requires like the remote session, right?
It's required for a remote session, but you don't need to execute a remote session on an EMR step. Well, that's the thing. Like we
Try.
you have to try things. It's frustrating. This is also why I warned everyone in here not to procrastinate on this project because it's full of crap like this. Dealing with EMR is full of crap like this, just everywhere. So, are there any questions on this error before we move on? Okay. What else?
Some permissions errors.
Yeah. Okay. So, yeah, those. I did have like service role doesn't have access to EMR. Yeah, okay. Let's address that. Service role cannot start EMR cluster. Okay. So what you need to do about this is you should add the Amazon Elastic MapReduce full access policy to your personal student user, so your AWS user, and the service role.
The idea of service role versus a user.
So the service role is the role that it contains the permissions that the EMR master node has to execute. Your service role is your permissions. What are you allowed to do as a user? So, you might be allowed to delete things in a certain EMR bucket, but you can restrict your EMR master node from being allowed to do that. You're like, I can remove stuff from this S3 bucket, but EMR isn't allowed to do that. So IAM, which is AWS's mechanism to control access to various services and what you're allowed to do in those services, it's possible to get very granular with the permissions that you allow.
So we're setting the service role is per our cluster or per the main node.
The service role is for your cluster. So you only assign one service role per cluster. You only assign one instance profile per cluster. So the instance profile is the access that the core nodes need also. Okay. Let's go to Amazon and actually I'll show you the name. Yeah. Yeah, I will kind of use both and I'll use them interchangeably. They refer to the same thing. Full access. It's going to be this one. Okay. Okay. Anything else on this Elastic MapReduce full access? Because Christine, I know you emailed me at some point to ask me about that. Okay. Did you have any other issues with it?
So after I fixed that one, another example, it had something to do with GC2 instance permissions in what. Yeah, and I think I fixed that one like slightly.
Yeah, did you need AC2 full access as well? Like modify in delete security group because like it should create route, modify image, run instances. I mean, EMR full access should be all that you need. I'd be surprised if you needed more. Provide full access to Amazon MapReduce and use underlying services that require, such as EC2 and S3. That's annoying. Why would you do that? You packaged everything together in a nice policy. Don't get rid of it. Why are you getting rid of it? That's heartbreaking. Okay, well, we don't care about the deprecation now because they're not going to deprecate it before the class ends. So You will probably set this up differently in real life, but also in real life, you won't have to worry about stuff like this because your developer will largely be created for you. So, like at Count, we have a specific setup for all of our EMR dealings, which is terrible because all of our clusters take like 40 minutes to start. It's awful. It's truly pain inducing. Trina has to do it more than I do. She's in even more pain than I am. And it's awful. Okay, other questions on this bit? We might also have to add EC2 full permissions, but I don't know if we do.
I was getting the EC2 errors first.
Okay,
And so I tried to go fix those, and then when I added the EC2 full permissions, then I was getting more, and then I went and added
okay.
the EMR full permission, so it could have been that if I had added the EMR first, it would.
It would have actually just fixed everything.
Maybe.
Yeah, could be. So yeah, optionally, you may also need EC2 access. Okay. Other things that we have questions on. Yeah.
And then when I try to read data from the S3 bucket,
Uh-huh.
it told me that it cannot find the S3.
Oh, that one. Yeah, we were talking about that on a Tuesday.
And that time you tell me like I need to change like the EMI version, right?
I've done something. I don't think it's that anymore.
When I start with EMR like 7.3, it still works.
Okay.
Too late, so I just do
I think I know what's going on. So in like the time that your code broke, did you SSH into the cluster and start the Spark Connect server before the cluster had finished bootstrapping?
let me remember that.
Huh?
I don't remember exactly that.
So you know how when you start an EMR cluster for like 5 minutes, it's in the starting state and then it goes into the waiting state. So if you SSH into the cluster, just SSHing is fine. But if you start the Spark Connect server before it enters the waiting state, it might cause that problem. Because what I think is happening is while it's in the starting state, it's downloading all of Amazon's custom dealings with S3. And so if you start the Spark Connect server, those jars will not be available yet. So they're not going to be loaded into Spark Connect. So even though the jars are available after you start the Spark Connect server, the Spark Connect server is already started and won't import again. So my theory is that because I was actually watching one of our older lectures from when I assigned project one, and this exact circumstance happened, is I started an EMR cluster and the SSH into the cluster, and then I started the Spark Connect server early, and it caused that exact problem. So that's my theory on why that's happening, is not all of the dependencies for Spark to connect with S3 have been downloaded yet. And if you start the Spark Connect server before it downloads all of those things, you're going to have that problem or other problems related to it. So don't start the Spark Connect server too early. Yeah, that's a good one. Let's write that down because this isn't related to an EMR step. Interestingly, that error will never happen on an EMR step because the step only happens after the EMR cluster is finished bootstrapping. So that error will only happen interactively. If it happens non-interactively on an EMR step, come talk to me because that is probably a whole other thing. Did anyone get that when running a step? Yeah, that doesn't surprise me. Okay. So that's my guess on like cannot find S3 Hadoop class. Is it something like that? Yeah. Don't I'll flesh this out later. Connect server to early. Okay. What else? This is a good list we got going here.
There wasn't really an error, but I think maybe this is gonna look like this, but at one point in my code, I repartitioned to speed things up. And when I did that, um. For whatever reason, it was just writing Parquet files for like each partition, which ended up being like over 1,000. And so I had to just repartition right before I wrote to Parquet to make sure that it was just like a couple. And that's.
Oh, it doesn't matter if it's thousands of files. I mean, that's perfectly fine. So like in your submission, I think you repartitioned to like 5 files and then each of them was like half a gigabyte. Which I would generally not recommend doing. So that file size is a little bit too large. What I would do is I would normally restrict it so that all of my partitions are maybe a maximum of 50 megs and then increase the number of partitions beyond that. That's what I would recommend doing is don't make sure your partitions aren't too big. So if you have thousands of files like in the result set, that's totally fine. Because when we read from an S3 prefix using Spark, it just reads all the files from that prefix anyway. Like the number of files doesn't really affect anything. It doesn't make it harder for Spark to read it in. Yeah. So you don't need to do that. It's totally fine to have thousands of files. I'm pretty sure in our identity pipeline at one point we write like 15,000 files to the same prefix. And all of them are like a gigabyte. It's so much data. Like the cluster we use for our identity pipeline has 6 terabytes of RAM. It's a monster.
Oh, I do have a question.
Yeah.
Have you? Can I ask you a question about the project? About spoil it.
Project 2.
Project 1.
Okay.
How big was your final data set?
It was about 175 million rows. Huh?
What's that in gigabytes?
I don't know.
Okay, because I did some snooping through AWS and I saw that like the results were all over the place.
So, well, it also depends on how many partitions they have. So if the files are smaller, but they have more partitions, it might even out differently. There's also the fact that some people created links between all pages, and some people created links between only articles. And I know I specified articles in the project spec, but my first implementation was actually for all pages. So even I got confused between articles versus pages. So if you did either of those things, you got full credit. So after I switched it to be, only between articles and not pages, it was about 175 million. So as long as you guys got some reasonable number, I was satisfied with it. And in fact, there was only one person's code that broke that I couldn't find the issue just by reading it. So I usually didn't have to compare the results directly, because that would have taken forever. And so I can normally just like look through the execution path because your cluster generates like in the SQL/data frame tab, it generates this really nice execution DAG and it tells you exactly how many rows were emitted from every stage. So it also allows you to find out like where things went wrong in the process if things did go wrong. So that's really cool. And I'll show you that page at some point. Actually, this session will not be recorded when I do this because I want to reassign this project again in a future semester because I feel like this project, it struck a really good balance of using a real data set that you can explore in real life because it's just the Wikipedia data set. Like you can go on a Wikipedia page and look at the links between the pages and then see if they appear in your data set. Like it's very tangible. And I think that's pretty cool. I think that aspect of it is pretty cool. I also think that it's sufficiently complicated because Wikipedia's data model is sufficiently stupid to not make this easy. And it's unclean enough. Yes. Yes. And so it is also realistic. The data is also realistically bad. So I like this project, especially where the Spark was concerned. I felt like it struck a good balance between being reasonably challenging versus being not trivially easy.
It was pretty cool being able to like manually sample the output and see like just actually go to the Wikipedia articles and make sure that they like,
Yeah. Yeah.
Especially things that you think this can't possibly be.
Yeah, and this Wikipedia data set is only from like a few months ago. It's from like September, so it's recent. It's very recent. Wikipedia publishes their dumps every month. And so before I gave it to you, I downloaded September's dump and turned it from SQL into something that's actually usable. Yeah.
maybe it's a little bit more of a nerd than how he was, and now I have a Wikipedia account.
Excellent.
Yeah.
If there's anything we should strive for in this class, it's increasing nerdery a little bit. Okay. Yeah. Mm-mm. You can just submit the Python file, and that's the entry point. What other errors? I know we had more than this. We only had a few people get to do the EMR step. I only had like 3 people submit something that worked with an EMR step. So we had to have more than this. And the second one doesn't even count. This can't be all. This definitely wasn't the only error we had. What else? Give me some more work with here.
There's the VPC thing.
Oh, geez. I remember that. Okay. So we should talk about VPCs. So let's go to the VPC. Let's go to the VPC for line. There we go. Okay. So VPC stands for a virtual private cloud. And a VPC is just like a virtual network for your AWS instances or EC2 instances to exist in. And does anyone know what a CIDR block is? Yeah, so a CIDR block is like a group of IP addresses that have a specific prefix in common. So what this CIDR block means, so does anyone know like how an IPv4 address is structured, like what these numbers mean? Can someone tell me what these numbers mean in an IP address? Okay, so these in an IP address are called octets. And so in an IP address, there are 4 octets, right? There are 4 numbers, each separated by a period, and each number is an 8-bit integer. So it's 1 byte. So every IP address is 4 bytes. And the way they did this is really stupid because they're taking an 8-bit number and representing it as in decimal form. So the maximum value of every octet is 255. And it's not immediately obvious that IP addresses do a significant amount of work with their prefixes. So what this means is like 172, what does that translate to in binary? Thank you, Google. Okay. Really? 172 in binary is that. Okay. Now it has .31 in binary. Well, I can do that. 2, 3, 1, 2, 3, 4, 5. Yes. And then 1, 2, 3, 4, 5, 6, 7, 8. And 4, 5, 6, 7, 8. Okay. So this IP address corresponds to 172.31.0.0. Okay. So the first 8 bits represent this number. For the next 8 bits represent this number. The next 8 bits represent the third number, and the last 8 bits represent the last number in this IP address. So what this CIDR block is, it's an IP address followed by a slash and then another number. This specifies the length of the prefix in the group of IP addresses. So basically, this this describes a group of IP addresses that all start with these 16 bits. And then every IP address that starts with these 16 bits, that's part of this CIDR block. Does that make sense? Okay. So let's say we wanted to split this. So this works with powers of 2. So every CIDR block is a combination of 2 other CIDR blocks that are half the size, right? So if we wanted to split the CIDR block up into 2 other CIDR blocks that are half the size, what would the blocks be? Well, that would be 256 times smaller because it's exponential, right? And remember, as you decrease the length of the prefix, the size of the CIDR block increases. That part makes sense? Yeah, because this specifies the length of the prefix. So if we were to split this into 2 CIDR blocks of the same size, how would we declare them? Hope I'm not waiting for nothing. You're trying to work it out. So almost. We can go to 17. So we can split these up into 2, right? So one's not 127, 172. Geez. 72.31.0.0/17. All right. This one is half the size because it uses 1 more bit as the prefix. So it has half the number of free bits, right? So instead of making these all zeros to represent a CIDR block, this one is represented by, let's represent all of these free bits as X's. So these bits can be anything. These bits are fixed. So let's say we needed to fix one more bit because that would produce a cider block of half the size, right? So what would these bits look like? So these bits would look like 1 0 1 0 1 1 0 0 2 3 4 5. All right, what would we do here? We're representing the free bits as x's and the determined bits as whether they're 0 or 1. It'd be 0. That's what this would look like. Does that make sense? Okay. Now what's the other half of this? What's the other side of this coin? Huh? Well, that would double the size of the cider block. So we just want the other cider block. So this block is a combination of two smaller blocks, and I'm asking which two smaller blocks make up this larger block. Yeah, it's another 17. But this is going to change. What does this change to? Yes, 128. All right. Who said that? Bhargavi, did you say that? Okay. So if this is 128, then what does this look like? Well, we just changed the 0 to a 1, right? Because that's 128. So these two cider blocks combined equal this cider block. That part makes sense to everybody. Kinda. Okay. Let's say we needed to find this guy's cousin. So there's another cider block that you can combine this cider block with in order to create another cider block that's double the size. So which other cider block would we combine this guy with? So think about how these free bits work. So, 0. We don't know what this number is. And we're not too sure about these. This is an essential component of how you define ranges of IP addresses when you're dealing with networks. This will be useful to you even beyond large-scale data analytics. Whenever you're dealing with something with networks, you will see cider blocks all over the place. So if you go into any engineering where you have to look at a network, this is going to be relevant to you. So this guy has a cousin, right? Some pairing that if you combined it with another cider block of the same size, you would get a cider block with a bunch of numbers slash 15, because that's double the size, right? So what would you combine this guy with to get a cider block of slash 15? Yeah, I think I've decided I'm going to make this an exam question. Something similar. Well, it wouldn't be 0.0 because you're only flipping one bit. You're only changing one bit here. So which bit would we change? So right now we're only looking for the other /16 pair, and then we'll create the /15 after that.
One closest to the X's.
Uh-huh.
So like you change that last one.
What do we change it to? Well, that's for the /15. What about for the /16? We're trying to find the pair for this guy. Yeah. So now this is going to be 30. And so when you combine these two, what do you get? What's your /15 cider block? So we know the bits in the cider block look like this now. Because it's a /15 now. Okay. What's this number? Be 30. Because in this situation, you know, we have the 30 here too, but since it's a /16 instead of a /15, this bit is set to 0. Over here, this bit is set to 1. So in the /16, all these other x's are all of these other free bits are going to be undefined for this cider block. So every possible value of 1s and 0s for all of these x's is part of this cider block, right?
It'll also be 31.
Huh?
It'll also be 31.
Well, no, because if it's 31, then that means this bit is defined. So by default, anything in a cider block that isn't part of the prefix gets set to 0. So this is not a valid cider block. And the reason that's not a valid cider block is because it has a prefix of 15 bits, but the 16th bit is set to 1 in this number. So because the 16th bit is set to 1, by default, whenever you're specifying a cider block, anything that is after the prefix is a 0. Is treated as a 0. So that means in a cider block, when you specify a cider block that encompasses every possible IP address, you know, our bits are 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. Right? So if we had a cider block like this, how would we express that here? It would be 0.0.0.0/0, because it has a prefix of 0. And so that means because we don't have like any prefix at all, that means everything after that is also 0. There are 2 cider blocks that make up this all-encompassing cider block. What are they? They're 0. Nope. /1. What's the other one? Huh? Well, not /0 because so I'm asking, there are 2 cider blocks that you can combine to make this cider block, one that's all encompassing. So this is the first of its children. What's the second children? What's the second child? You said 0.0.128. So if we did 0.0.128, what that would look like is in the bits. That's what 0.0.128.0 would look like. But that can't be right because this bit is way past the first bit. Because we know this is the only bit that can be defined because it's in the prefix. Everything after that is undefined because it's just part of the range. So the other half of this cider block, so 0.0.0.0/1, the other half is going to be 128.0.0.0/1. That's what the other half is going to be, because this guy has these bits, and its cousin has these bits. So that's where the 128 comes from. So this is how you create cider blocks. Does this make sense to everybody? Huh? How did I find that it's 128? So, because that's what this number is. If you replace all the x's with zeros, that's how you get 128. See, watch. So if you tell Python to interpret this as binary, that's what the 0b, 28. No, none of the bits are defined, or none of the bits are defined because the prefix length is 0. So that means you're encompassing all IP addresses. When you express it as a cider block, all undefined bits get set to 0. Make sense to everybody? So we go back to our VPC that I have in my account. It's this cider block, and the prefix is 16 bits long. So that means that there's a certain number of IP addresses that fit into this cider block, right? How many is that? Huh? No, 2 to the power 16. Right? Because all of those 16 bits are free bits. So it would be 2 to the power 16 possible values of those 16 bits. And I don't even know what that number is. Let's find out. It's like 130, nope, 16, whatever that number is. That number. Okay. I know we spent a lot on cider blocks, but I feel like this was good. Because a cider block is expressing a lot with a little. There's a lot of information here. And it's something you have to understand when you're looking at anything network related. And you have to deal with network related stuff all the time when you work in AWS. So it's good to understand this kind of thing. Any questions? Lovely. Bye. Unless I'm seeing you after class.